Okay, so last time we talked about the properties of a normal distribution and the area under the standard normal curve. So this lesson is just a continuation of that. So we will see the applications of a normal distribution. So we know that the scores under the standard normal distributions are called z-scores. Now, how do we convert a raw score X into a z-score? And that will be our topic for today. So in this lesson, you are expected to convert normal random variable to a standard normal variable and vice versa. When you say vice versa, you are also expected to convert a standard normal variable into its corresponding normal random variable. Okay? So without further ado, let's do the introduction here. So any normal distribution can be transformed to standard normal distribution. How? It's by using this formula. So here, z is equal to x minus mean over standard deviation. Okay? Where x refers to the raw score, while the mu refers to the mean, and the sigma refers to a standard deviation. Okay. Now, each values of obtained using the given formula is called a z-score or a standard score. Now, if your value is already in standard score, that is the time that you will be able to use the z-table. I hope you still remember the z-table that we discussed last time. You still remember how to use that? So z-score or standard score tells how many standard deviations of values away from the mean. That's why recalling this figure, so in a standard normal distribution, the mean is always on the center. Now, going here on the 1 means that the score here is 1 unit away to the right of the mean, while the score here on negative 2 means that 2 units away to the left of the mean. Okay? So a negative z-score tells the value is below the mean. That's why it's on the left, and that's why it's negative. That's why it's below. While a positive z-score is above the mean. That's why it's positive and on the right of the mean. A z-score is unitless, meaning it has no unit like centimeter or whatsoever, decimeter, kilometer. So we do not apply that on the z-score. Okay? So to further mm, clarify things, let's have some certain examples here. So remember, our goal here is to learn how to convert an X score to a Z score. So for example, the scores of students in a midterm examination for math has a mean of 36 and a standard deviation of 5. Find the Z scores that corresponds to each of the following. So for letter A, find the Z score that represents 41. For B, a z-score that represents 31. C, a z-score that represents 37. And D, a z-score that represents 30. So here's the solution for that. Since a computation is kind of simple, I did it like in a straightforward manner. So when x is 41, recall that on the given problem, mu is 36, while standard deviation is 5. You simply use the formula z, x minus mu over standard deviation, that's 41 minus 36 over 5, simplifying things, that is 5 over 5, or that is 1. So meaning, the score that corresponds to 41 is 1. So, so it makes sense because imagine 36 is in the middle, right? Because that's the mean. Remember, the mean is always on the middle when we talk about standard normal distribution, and the standard deviation is 5. Okay, so meaning If you add 36 plus 5, that's 41. So in standard score, that is 1. Meaning this 41 is 1 unit away from our mean of 36. Okay? So next is 31. So as you can see, 31 is lower than 36. So you are expecting that the answer here would be negative. Okay? So x is 31, substituting it, 31 minus 36 over 5, that's negative 5 over 5, that is negative 1. Okay? Seems like pretty straightforward, right? Next is 37. Okay? Now, not all the time we get a whole number as an answer. Sometimes or most often, it's a decimal. Okay? I advise you always convert it on decimal since our table is represented on decimal, not in fraction. So substituting the values here, 37 z is equal to 37 minus 36 over 5 is 1 over 5, or in decimal that's 0.2. You just simply press on calculator 1 divided by 5 to get the decimal representation. Okay, next. When x is 30, still mu is 36 and SD is 5. So substituting it on the formula, 30 minus 36 over 5 is equal to negative 6 over 5 or negative 1.2. Okay? Alright, so that's the end of the example for converting an x score to a z score. Now, let's try to explore different example. This is the application of that. So for example number 2, let's say we have a normally distributed random variable x. Okay, imagine you have a normally distributed random variable x that has a mean of 90 and a standard deviation of 8. Find the value of x below which 85% of the scores will lie. So what does it mean? Remember, if you will observe this problem, you are supposed to find the value of x that lies below the 85% of all scores. Okay? So take note of that. We are finding the values of x. Now, one way to see how would you attack the problem is to look at the givens. Okay, so here we have a mean of 90, a standard deviation of 8. Do we have a value of x? No, that's the value that we are looking for. How about the z? None as well. Now, what's the purpose of 85%? Remember last time, we talked about the area under this curve. Okay? So if you can still remember, from 0 to 1, that's 34 point something percent, meaning that's 36, 0.36 something in decimal. Okay? So here, we have a given of 85%. So in decimal, that's 0.85. Now, where can we start if we have a given of 0.85? Remember, percentage refers to the area under the graph or the bell-shaped curve. Now, let's look back on our table to see if there is a 0.85 there. Because remember, the table here, the values here on the table represents the area under the normal or under the curve. Okay? So let's see if there is a 0.85 here. Okay, we're almost near. Okay, so here, if we will notice, there is no an exact 0.85 value. So the nearest value in 0.85 are 0.8485 and 0.8508. So we will get those values. Okay. So we find the value of